Hey, I'm Dewey with Fujikura Kasei. Today I'm going to talk to you about a completely new material that we've never presented publicly before, our stretchable silicone-based silver chloride inks. First, who are Fujikura Kasei? We're a Japan-based producer of polymer materials for a variety of applications, developing value-added products based on our decades of accumulated experience. We have our coatings for plastics division, paints division, medical materials, functional polymers, and the electronics materials division. In electronics materials, we make Dotite. Dotite goes back many years, as we were the first in Japan to make electrically conductive adhesives for electronics in 1957. So what is Dotite? Briefly, Dotite is a combination of binder resin, functional filler, usually silver, solvent, and other additives to improve performance. We refer to it as a paste in Japanese, but variations can be used as adhesive, paint, or ink. We work with a variety of resins for different applications: acrylic resin for paints, epoxy for adhesives. And when it comes to stretchable inks, we looked at our catalog and identified two materials with the necessary properties: urethane and silicone. We had extensive experience printing with urethanes and expertise using silicone as adhesives for precision electronics. We leveraged this know-how in working with these pastes with our extensive experience with screen printing to develop stretchable inks. For both our urethane and silicone-based inks, we developed a full stack of materials, which you can see here: silver electrically conductive ink, electrically insulating ink, conductive carbon ink, and a pliable adhesive that's compatible with stretchable electronics. And for silicones as well, the full stack of silver electrically conductive ink, electrically insulating ink, carbon ink, and a stretchable compatible adhesive. This full lineup of materials allows for printing stretchable electronics on silicone substrates for wearable and medical electronics. Both our urethane and silicone inks have been utilized in mass production projects, though unfortunately I can't share information about them publicly. So these are tried and tested stretchable inks that can maintain conductivity when stretched up to 100% and are optimized for repeated stretching of around 20%. It's important to point out that we work closely with our project partners to optimize our materials for their needs. So as we work through improvements on our stretchable inks, one request we repeatedly received was for stretchable silicone inks utilizing silver chloride filler for medical electrodes. Standard silver chloride inks for flexible electronics were fine, but they forced the user to have a rigid, non-stretchable segment in any medical device they tried to print. We combined our know-how with silver chloride inks, seen here, XA3513, and stretchable inks to make two variations of silicone-based stretchable silver chloride ink: Dotite XA9576 with a 90-10 silver to silver chloride ratio, and XA9577 with a 70-30 ratio. These materials are designed with two main applications in mind: ink for standard medical electrodes, the 90-10 version, and ink for iontophoresis-based medicine delivery systems, the higher silver chloride content 70-30 version. They're compatible with our other stretchable silicone inks and can be used in a full stack as seen in this diagram here. These materials were developed only months before the COVID pandemic, and so they haven't been publicly presented in trade shows or other events. So we're excited to share them with you today. We believe these materials can play an important role in stretchable electronics because they allow for the first time a fully stretchable medical device from the lead lines all the way to the contact electrodes without needing to utilize a standard flexible or rigid material for any part of the printed circuitry. We envision these materials being used in wearable devices like t-shirts with built-in medical sensors for athletics, or wearable heart monitor halters for continuous health monitoring. The stretchability and softness of silicone will allow for a more natural, comfortable feel, making continuous wear easier for the user while opening up new design possibilities for the electronics designer. If you have any questions about our silicone-based stretchable inks, our urethane stretchable inks, or any of our other inks for in-mold and printed electronics, feel free to contact me or visit our virtual booth here on Spatial Chat. Thank you very much.